Assalamualaikum warahmatullahi wabarakatuh. We are from AS1205L. We will presenting about caffeine in coffee sample.
For introduction, coffee, one of the most consumed beverages globally, owes its popularity to its unique flavor, aroma, and health benefit. Among its numerous bioactive compounds, coffee stands out as a natural stimulant influencing cognitive performance and alertness. This study investigated the coffee content in coffee samples from Volga, Ethiopia using two prominent analytical methods. First, HPLC and second, UV vesicle spectrometry. By comparing these results from this technique, this research highlights the influence of geographical origin on coffee level and emphasizes the precision and applicability of this method in assessing coffee quality.
HPLC is an analytical method to separate the components of mixture by utilizing the liquid mobile phase. It used to separate the chemical mixture, including non-volatile and thermally unstable compounds. From this experiment, the coffee samples were injected into the column with flow rate of 0.8 ml per minute using water and methanol as mobile phase. Methodology of coffee sample preparation. First, coffee beans was roasted, then cooled at room temperature. Second, the coffee bean samples was grounded, then sieved to get uniform mixture. Third, the coffee samples was first dissolved in water, and then the caffeine was extracted from the aqueous extract using dichloromethane. Method. The analyte will be injected onto the top of column. As the analyte and the mobile phase pump through the column, separation will occur. The column temperature was kept at 30 degrees Celsius. Chromatographic data for caffeine were collected at 272 nanometer. Linearity of the calibration curves was evaluated based on the magnitude of R-square. Accuracy was validated by using spike recovery method. Each bit represents each component.
The objective is to determine the caffeine in coffee sample from Dongoro, Sasiga, Gida Ayana, and Sibusir district in Walega zones of Western Ethiopia by high-performance liquid chromatography, which is HPLC, and ultraviolet visible spectrophotometry UV visible method. So for the result, which is HPLC method, the caffeine content range from 0.78% to 1.128% in W/W, which is stand for weight of solute dissolved in weight of solvent, and the highest caffeine content was found in Abedagor, which is 1.12%, while the lowest was Sasiga, which is 0.78%. So for the UV visible spectrophotometry method, the caffeine content range from 1.322% to 2.05%, and the highest caffeine content was in Abedagor, which is 2.052%, and the lowest was in Sasiga, which is 1.322%. Next, we go to the comparison of the result. So, UV visible spectrophotometry is consistently reported higher caffeine content compared to HPLC. A significant difference was observed between the caffeine content result obtained from the two methods, which is P is less than 0.05, and therefore, both methods were effective for caffeine determination.
And now, I will talk about discussion of this topic. The study successfully determined caffeine content in coffee sample from Walenga, Ethiopia using high-performance liquid chromatography, HPLC, and UV visible spectrophotometry methods. Both methods were reliably by UV spectrophotometry consistently identified higher amount of caffeine than HPLC. The amount of caffeine in the sample varied because of things like where they come from, how they were grown, and the weather. Abe Dongoro coffee had the highest concentration. The results are in line with what has been said about caffeine level in Ethiopia coffee, and they show how important it is to choose the right method for analyzing caffeine. It is suggested that more study be done to look into other factors that affect caffeine level and to make the statistical strength of the result stronger.
In conclusion, this study successfully employed HPLC and UV visible spectrophotometry to analyze caffeine content in coffee samples from various districts in Volga and Ethiopia. The finding revealed significant variation in caffeine level based on geographical origin and demonstrated the higher sensitivity of UV visible method compared to HPLC. This result aligns with the existing literature on caffeine variation in coffee, emphasizing the role of environmental and genetic factors. Further research incorporating border sampling and analysis of other coffee compounds is recommended to deepen our understanding of Ethiopian coffee biochemical profile.